Greetings and welcome to my new calculus channel. My name is John Gabriel. So in the previous episode of Rudin's bullshit analysis, we dealt with limits and uh, some various metric spaces. And in this video, I'm going to show you how things took a very drastic turn downwards. So this was how Rudin defined a derivative. He says the derivative of a real function. Basically says let f be defined and real valued. This is actually totally irrelevant. In fact, the only requirement is that this f here, must be smooth. And what does that mean geometrically? It means that it must be defined everywhere without breaks, and there must only be one tangent line possible at each point in the interval. Okay, so that's what smoothness means. Now, this moron, all the downhill crap that you've got in mainstream mathematics began with this guy. So you can't just define things out of your whimsical notions. You need to have uh, well-formed definitions. Okay, and you'll see in just a moment how he actually slips up badly. He's quite an idiot and doesn't he never knew it, and his colleagues didn't know it because they're idiots like him. And the morons who teach this stuff today are also idiots like Rudin was. So he also took careful. He was also cautioned not to mention geometry, by the way, because this was the beginning of the agenda to delete geometry from calculus. But here's the thing, people. Calculus is geometrical. It's based 100% on geometry. There is no other calculus. The only calculus that you can get is the one that's based on geometry. So there were more efforts continue on from what idiotic Rudin did and his followers. So the derivative was reborn as an operator. So typically you'll have d interpreted as an operator, and sometimes you'll have d like that with a half, which is meaningless garbage. And it's some exotic forms where you're doing division of derivatives and just really insane, illogical, unreasonable stupidity to the biggest extent. Okay, and so he says here, let f be defined on the interval ab inclusive. Then he says f is differentiable. If f is differentiable at a point, then f is continuous. Okay, well, that's actually circular. If f is differentiable, it's not only continuous, it's smooth. Do you see what I'm saying? So here, look, if you have a curve like that and you're considering this interval here, well, first of all, the definition of a tangent is that it touches only at one point and does not cross. Let's do this properly. Touches only at one point, it does not cross at the point of tangency. It can cross elsewhere, but not at the point of tangency. Then the definition of an interval, which is of a function which is smooth over an interval, is one where only one tangent line can be constructed at each point in this interval. Okay, at each point in this interval. So already you have circularity here. Okay, and then of course it goes downhill very drastically from there. And instead of talking about Rudin's bullshit, I'm going to pull you back to the original definition of derivative, and you might understand something if you pay attention. So, look, the tangent line problem was not one of setting up an operator or trying to define continuity or smoothness. Those things were taken as givens. Get that into your skulls, morons. They were given. You cannot do calculus unless you have a smooth function. Learn that. Okay, so now what does that mean? It means this is an illustration of Newton's method and Leibniz and all the other fucking morons that came after him. So if you are trying to get close to that point, the secant line is supposed to approximate. Of course, it's garbage through and through because it's not defined at that point, okay? It's not defined here. So this was the problem that they were dealing with. Now, you can say stupid things like given a difference quotient. What do you mean by that? F must be smooth, okay? You can't just say, oh, look, let's use that difference quotient. It's got to mean something. What does it mean, you incorrigibly stupid morons? Tell me what it means. Stop the video and think. Yes, that's right. It means the secant line here has a slope, okay? And it's not a secant line unless it falls on the curve, which means the curve is defined everywhere here in this region. And there is no tangent line possible here unless it's smooth. Get it, you idiots? Do you understand that? Okay, so look, your professors are absolute imbeciles. I'm trying to draw in here. I don't know why I can't. Anyway, doesn't matter. I'm going to get rid of this. So you have tangents all along here, okay? Meaning that you cannot even talk about a difference quotient like that unless the curve is smooth. Idiots, get it into your skulls. Right. So I actually did fix your broken bullshit calculus with my historic geometric theorem. This is it. The one that you see down here. See? This is it. And now, if you want a comparison between my calculus and the bullshit mainstream calculus, you'll see that my calculus is always correct. Okay. My calculus always gives the correct quotient. Always. It's always the correct value. Right? Never changes. So this is because I actually moved this damn red point. I think it's supposed to be there. Yeah. Let's see here. All right, I've done something here which has moved this. Let me just reload this damn applet. New, discard, open, downloads, Gorshi Klooch. Okay, so if we do a comparison, here's the comparison. So the tangent line slope is 1.16, okay? And in the new calculus, it's always correct, okay? Always correct. So the gradient will be the same as that of the tangent line, which is what in this case? Which is, let's get a slope on there and you'll see. Settings, slope. Not there. Gosh, when I'm trying to get things done, let's do an algebra view. Okay, algebra. Come on. Okay. Algebra. And then we want to say the slope of this curve, which is slope of A, like that. Okay, so as you'll see, it's -3, okay? So this point here obviously has to be moved as well. If you move this closer to this point like that, it's exactly -3, okay? And in the new calculus, it's defined. In your bullshit calculus, it's not. In the new calculus, it's defined because you have a parallel secant line. See there? That green line is a parallel secant line, okay? So I don't know why the red point is moving there. It shouldn't really be moving. Okay, anyway, so the gist of this is that contrary to what Rudin is telling you in this chapter, calculus is geometry. So you cannot divorce the two. You cannot have circular definitions like this. If f is differentiable, then f is continuous. Excuse me, you can't say a function is differentiable unless you know f is continuous and smooth. So that's the one thing I want you to take away from this, okay? The first thing. Now, hundreds of crap real analysis books have been published after this. And some of the most famous ones by idiots like Terence Tao and Gilbert Strang and all those morons. Now, there used to be a discussion on this on sci.math again. Lots of idiots there, fools like Jean-Pierre Massage from France, incorrigible buffoon, and many others. The Marcus Clivers, basically, of mathematics. And they don't understand where these things come from. And in their minds, mathematics is something that is done by rules and definitions. Any definitions they like. They don't really have, let's say, a rule on making definitions. They can pull a definition out of their ass. because they don't rely on mathematics anymore. They deal with topics like logic and set theory and topology, which is based on set theory, and real analysis, which kind of describes all of them. Okay. Excuse me. So that's pretty much it. If you're not already subscribed to my channel, become one. Tell your friends about this channel, this great channel. Click like. Don't forget to click like. Follow me on academia.edu and look forward to the next exciting episode. I don't know if I'm going to do much more with Rudin. He doesn't really have anything else of interest to say. If you look at his real analysis book, he goes into crap like measure theory, Lebesgue, integral, Riemann-Stieltjes. All of that is absolute bullshit, which is used nowhere, has been used nowhere in practical use. Is not, for example, a Riemann-Stieltjes interval is not a well-formed concept. Neither is Lebesgue integral and integral. It's basically a contraption of moronic concepts in mainstream mathematics mind. So that's pretty much it. Till next time, goodbye.